to this class. Today on transcendental function of differentiation, I mean disposing some functions of differentiation known as the exponential function, the logarithmic function, and trigonometric function, such as sine, cosine, sec, cos, sec, etc. So for today, let's start with exponential function of differentiation. So what's the concept here? Let's say I have y to be equal to exponential x. If I differentiate y with respect to x, I'll have that the y over the x is equal to exponential x. So note that if I differentiate exponential x, I'll have exponential x. That's the concept. Now, why is it that if I differentiate exponential x, I will have exponential x? I will prove this. This is what we call the series expansion method. Right? Note something. Note that exponential x is equal in value to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the power 4 over 4 factorial plus it continues. So this is the real value for exponential x. Now, we are hearing the word factorial, factorial, factorial. So what is factorial by definition? A factorial is simply the multiplication of consecutive terms in descending order such that each term differs multiplied by 1 until 1. For instance, if I have 5 factorial, 5 factorial is obviously what? 5 times 4 times 3 times 2 times 1. That's 5 factorial. If I have 4 factorial, it's simply 4 times 3 times 2 times 1. If I have 3 factorial, the same way, 3 times 2 times 1, 2 factorial, because what there? 2 times 1. 1 factorial is what? 1 times 1. This is factorial. Now, what I want to observe from this factorial is that if I have 5 factorial, I can write 5 factorial as 5 times 4 factorial. Why? Check. 5 factorial is this. But 4 factorial, 4, 3, 2, 1 are in 4 factorial, 4, 3, 2, 1. Obviously, I can represent all this as what? 4 factorial. That's the relationship. If I have 4 factorial the same way, I can say what? 4 times 3 factorial. The same way, 3 factorial can become what? 3 times 2 factorial. Also, 2 factorial becomes what? 2 times 1 factorial. So, observe this relationship, please. Observe this what? Relationship. Okay, now let's prove this concept. We just said that, let's say I'm given y to be equal to exponential x. I'm going to differentiate this. Now, note that y is not equal to, we said the real value for this is what? All these people here. All these people here. So, I'll have 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the power 4 over 4 factorial plus it continues. Now, let's say I'm given this question that y is equal to this. I'm going to differentiate this. So, what do I have? I'll have that I'm differentiating y with respect to what? X. So I'll have what? The y over the x to be equal to differentiate 1. That's what? 0. It's off. Next up, differentiate x. I'll have what? I'll have 1, right? Next up, plus, I have a plus sign here. Differentiate this one alone. 2x. That becomes what? Sorry, x power 2. That becomes what? 2x over, if I differentiate x power 2, I'll have 2x over 2 factorial. But this is 2 factorial is what? 2 times 1 factorial. So I'll have 2 times 1 factorial. Next up, plus x power 3. If I differentiate x power 3, I'll have what? 3x squared over time, x power 4 is simply what? 4x power 3. General method, please. Over 4 factorial is what? 7 factorial is what? 4 times 3 factorial. 4 times 3 factorial plus it continues. So at this point, observe something, please. The y over the x is now equal to 1 plus, listen, I'll have 2x over 2. So listen, I can say 2 cancel 2, right? 3 cancel out 3, 4 cancel out 4. So I'm left with what? 1 plus x. Observe, x over 1 factorial is what? Is still 1. So if I put over 1 here, I'm still what? Having x. So plus x squared over 2 factorial plus x cubed over there 3 factorial plus it continues. Observe, when I differentiated y exponential x, I still have what? That same value. Compare, see, listen, this same value here, I'm still having that my answer here. So that's the reason why that if you differentiate exponential x, you have exponential x. So let's an example and explain this concept. Let's say y is equal to exponential 2x. I'm going to differentiate this using I'm going to differentiate this, right? So what do? Your first start is that since you are differentiating y with respect to x, you have what? You have an x. But your first start is that call this one here, call this one u. So let u to be equal to 2x. Differentiate u with respect to x. How about that? The u over the x is equal to 2. 2x is 2 by what? General method. Next up, from the question, y is equal to exponential what? 2x. But we just said 2x with what? U. Exponential u. Differentiate y with respect to u. I have that the y over the u is equal to exponential u. Why? We said y is equal to exponential x. From here, we said y is equal to exponential x. Whoever this is what? Exponential x. So if I differentiate exponential u, how about exponential u? So at this point, I will apply chain rule. So listen, please. For this concept here, we're going to apply chain rule the most. So note that I don't have mind that chain rule is one of the ideas to apply to solve problems on all these functions. So at this point, using chain rule, so I'll have that the y over the x for chain rule is what? The y over the u times the u over the x. Sorry. So at this point, the y over the x is now obviously the y over the u is what? Check. The y over the u is what? Exponential u. So I'm opposing what? Exponential u multiply the u over the x. Check. U over this is what? Obviously 2. So I'll put in 2 here. To multiply the 2 together, I'll have 2 exponential u. I'll have the y over the x here. 2 exponential u. But I can't express x in terms of u. So take u back to x. But we said u from the question is what? 2x. So put in 2x here. So anywhere you see u, you put what? 2x. So at that point, I'll have that. Alright, I'll put in u here. So at the end, the y over the x is now obviously equal in value to 2 exponential u is what? 2x. 2x. So here is the idea to solve problem on exponential function of differentiation. In our next class, we're going to discuss on the shortcut to solve problem on exponential function of differentiation.